Okay, so the next step in our pursuit of understanding the atom is atomic structure. What is the atom built like, right? So we figured out in section 2 that there was such a thing as an atom, thanks to Lavoisier and John Dalton. We figured out, thanks to J.J. Thomson and Robert Millikan, in section 3, that there was such thing as an electron. So they're looking at this atom and they're saying, all right, so there's a little small piece that can be broken off, and it has a negative charge on it, but the atom itself is neutral. So two models were suggested, the Plum-Pudding model and the nuclear model, and both of them came out of Cambridge. The first one, the Plum-Pudding model by J.J. Thomson, he was the one, remember, who discovered the electron, the existence of the electron, and found the mass-to-charge ratio with the cathode ray tube. He suggested in the early I've lost here. Yeah, there we go. The Plum-Pudding model. He suggested in around 1900 that the atom was made up of a sphere of positive charge with little electrodes, which may have looked like, I don't know, little plums or little raisins or something inside the pudding. Little electrons interspersed throughout the positive charge. He had a guy that worked for him named what was his name? Rutherford, Ernest Rutherford. And Ernest Rutherford set up an experiment to confirm J.J. Thomson's theory, the Plum-Pudding model, and the experiment looked like this. There was a gold foil, which was essentially gold that was pounded down to really close to very, very thin, close to an atom thick, right? Very thin gold foil. And they took alpha particles, and that is, where am I here? They took particles that some source, right, which made alpha particles. They didn't even know what those alpha particles were, just some sort of source of radiation. And they would come through here. So here's your source of radiation. And when they went through these little particles, the idea was that if the Plum-Pudding model was correct, that the particles would go straight through. What Ernest Rutherford found, however, was that they would actually bounce off. They would get to that gold foil. Some of them would go through. Actually, a lot of them would go straight through, but some of them would glance off the side of something in there, right? Which turned out to be the nucleus. These alpha particles would glance off the side of this gold atom, and they would bounce over here. Some of them would hit it with a greater angle of incidence, and the alpha particle would come over here and be detected by this film around here. Okay. Some, even fewer yet, right, would actually hit a nucleus head-on or close to head-on and be bounced almost directly back. Okay, so this was the experiment that Ernest Rutherford produced at University of Cambridge, or performed at University of Cambridge, to confirm the nuclear model of the atom. So here's the nucleus, right? These alpha particles are coming through. Some of them are hitting off the side and bouncing a little bit, right? Most of them are just going straight through. The electron cloud is here. And some of the particles are hitting it, pretty much straight on and getting bounced back. Okay? In this picture, by the way, the red particles are protons, and the blue spheres are meant to represent neutrons, and the electrons are racing around like so fast you can only see them as a yellow cloud over here. Again, the Plum-Pudding model, the idea was that the alpha particles would go straight through the atom. Okay? So Rutherford disproved the Plum-Pudding model of the atom and suggested instead this is the model of the atom. So the nuclear model of the atom has got these main points. Most of the atom's mass and all of its positive charge are contained in a small core called the nucleus. Most of the atom's mass and all of its positive charge are in the nucleus. Most of the volume of the atom, by the way, is empty space, throughout which tiny negatively charged electrons are dispersed. So the electron cloud, going back here to this picture, the atom is mostly, right, this all yellow thing is the atom, and the nucleus is a really tiny thing in the middle. So most of the mass is here, right? This is mostly empty space. Electrons are racing around here. That's the second point. Most of the volume of the atom is empty space, throughout which tiny negatively charged electrons are dispersed. And then finally, there are as many electrons as there are protons. Right? Watch this. There are as many negatively charged electrons outside the nucleus as there are positively charged particles, protons, inside the nucleus, so that the atom is electrically neutral.